Hello, this is John again from Poor Man's Garage. I want to show you that on this tool, you have to make sure that the point of this tool is in the exact location on the connecting rod. So basically this is on the head of the bolt, and this is on the bottom of the bolt. And it's kind of want to show you how you do it in the motor. It's a bit of a pain in the butt. And then you kind of got to roll the gauge around, roll it around until you find your smallest dimension, and that's what it is. So basically it's got to go just like this, which you kind of got to feel it. Can't really see it, so you got to lift up on the gauge, and you got to make sure that that point is in the pocket of the bolt on the connecting rod. Just like that, I can kind of feel it that it's in the pocket because the bottom doesn't want to move around. So then you let the dial go, so then now it's on the top of the bolt, in the pocket at the top of the bolt, and then you kind of roll the gauge around, you keep rolling it around until you find the smallest dimension. Once you find the smallest dimension, and it stays there, because as you roll it around it kind of bounces. But once you find that small dimension, you gotta hold it on that small dimension. Like this is 9. The smallest dimension on this is 9. So I know on number 6 rod, and I got it marked out on the inside bolt, number 6 rod, I know that it's 9. So then I mark it in the chart, number 6 rod, inside is 9 thousandths. And then I gotta subtract it from what I originally had, and make sure that it's between 5 and 7. It doesn't stretch any bigger than 7. So that's I know it's a bit of a pain in the butt. It takes a little bit of getting used to, but that's the way you gotta do it. Okay. See you soon. Okay, hello again. This is John, Poor Man's Garage. Okay, so all the connecting rods are all torqued down. The feeler gauges in between them, torqued all the connecting rods down. And then I checked the rod bolt stretch with the rod bolt gauge. All the rods fall between 5 and 7, just exactly what the Carrillo sheet showed us, between 5 and 7. That's where they wanted it to fall. Most of them are at 5. I'll show you the sheet. Okay, here's my sheet. This is before. Take for instance, before I torqued this, I had 2.5 thousandths. Now I got 9. So anyways, that's them all. They all fall between 5 and 7. So, okay. And there's the block. The arrows are all pointing towards the front of the block. On this side, the arrows are all pointing towards the front of the block on this side. So anyhow, that's where we're at. The motor turns over real nice, no problems there. We know that our pistons are all, rings are all loose in the bore. Move on the pistons inside the bore. So now I am going to talk to you about our next move is going to be distributor, and I'm going to show you and tell you what we're going to do there, what to run, what not to run. All right, see you soon. Hello again. Okay, I'm pretty much the next move on this motor is going to be the distributor. All right, so let's talk distributors here. I want to talk to you a little bit about distributors. Okay, basically there's 3 different kinds of gears, well 4 different kinds of gears you can buy. You can buy a cast iron gear, which you don't want to use. You can buy a steel gear, which you don't want to use. You can buy a composite gear. This is the new thing, the greatest and the latest. is a composite gear. You don't want to run that either. You want to run the old bronze gear. I'll show you the reason why you don't want to run a composite. You don't want to run a composite because the first time that you start the motor in the cold weather, this is what happens. This is a composite gear. It's composite being plastic. This is like $150. But when the brass one's like, I don't know, $50. So this is what happens. So you go to fire up the motor on a cold day, what happens is because it's made out of plastic and the oil's cold in the motor, and you know, because your cam, when you start the motor, your crankshaft turns, which in turns your timing chain turns your camshaft. Camshaft tries to turn this, and this is hooked up to your oil pump. So when the cold weather comes along, you turn your motor over, it strips the composite gears off the distributor because this is plastic and it's not strong enough to turn that oil pump when it's cold. So no composites. Okay. So so the other thing is MSD gives you this dimension. Here's MSD. I don't run MSD distributors anymore. I don't run MSD anything anymore. I've talked to them. I'm not going to tell you the reason why, but I've had some problems in the past. Right now, I run a crane box, crane distributor. That's what I'm running. You guys run them whatever you want. So, anyways, there's the dimension there. There's the dimension that MSD gives you. See the dimension there? And you can see there's the dimension that I have. So MSD says anywhere between 3.96 and 4.005. So 4-inch 5/1000s. Okay. So this is MSD. This is there. Okay. Here's SVOs, Special Vehicle Operation, Ford Motorsport. Okay. There's their dimension. There's Ford's dimension. I'll make it a little bigger for you because I blew it up. There it is. And I crossed out theirs too, and I put in what mine ended up being. Okay. So Ford SVO says 4-inch 31,000, so to 38. So Ford says 4-inch 31,000s to 4-inch 38,000s. MSD says 3.996 to 4.005. So MSD says at their largest 4 inches 5/1000s. Okay, so I find it to be closer to Ford's dimensions than MSD's dimensions. So now I'm going to show you exactly how you're supposed to do it, the right way to do it. So, because the blocks are all different, then maybe MSD's might be correct. Maybe Ford's might be correct, okay? You know, you don't know, so I'm going to show you exactly what you do to get the exact dimension that you need. Because you got to remember the way that the way the motor works on a Ford, the cam's always trying to run the distributor gear into the block. So the camshaft, the way the camshaft rotates and the way the gears are made and the way the gears and the distributor are made, it's always pulling the distributor gear down. It always pulls it down. So now you might be able to get away with MSD's dimension, that 4/5,000s, if you had a lot of play in your shaft, and you set this gear, if you pushed it in and set it, and if you had say 20,000s play, and you could pull the shaft out, you know, if it dropped out 20,000, you might be able to get away with that dimension. But you can see there's a little bit of play in there, just a little bit. I think it ended up being about 6 thousandths on the MSD. Okay. So on the crane, there's no play. There's a little tiny bit, maybe 1,000. So this has to be, more accurate than the MSD. So if you did have a lot of play in your shaft, and you pushed it in and set it to that dimension, and you had 30 thousandths play, what would happen is when you put in a motor, basically this gear would be riding on the block because the cam's going to be constantly pushing that distributor gear down. Okay, so now, let me show you the right way to do it. So now you remember that this is the distributor out of the box. You're going to pull it out of the box. You still got the cast iron gear on it. Okay, I don't care if it's MSD, I don't care if it's crane. They're going to give you cast iron gear. It's unfortunate you'd think they put the brass gears in there, but I know the reason why they do it. Like I said, they got to sell camshafts, So if you burn out camshafts, the more camshafts they sell, the more money they make. So obviously they're going to put the cast iron gear on there because they got to sell camshafts. So if you're smart enough, right away, don't run that cast iron gear, no matter what. I don't care if you got a cast iron camshaft in there. I don't care if you got a steel camshaft in there. If you put that cast iron gear in that motor, you will put metal chips in the motor. It will destroy it. So anyway, I'm going to show you here, if I can. So, you see the motor? Okay, so, you take the distributor, you still got the cast iron gear on it. Okay, you put it in the motor, like that. Put it in the motor. Make sure it's all the way down. The camshaft's not in the motor now. Then, you take your hole down. That's your hole down. Put the hole down on it. Just like that. If you have your motor all together, unfortunately, to do it the right way, you're going to have to pull the front of the motor apart, unless you're going to guess at it. And I ain't a guesser. I don't guess on nothing. When I do a motor, I know exactly what it is. So unfortunately, if you're changing out the distributor to do it the correct way, without guessing, because this dimension from here to here is different on every motor. So to do it the right way, you have to pull the front of the motor off. It means everything's got to come off the front of the motor. You got to get it down like that, except the camshaft. You could actually leave the camshaft in there, but you still got to pull the timing gear. Okay, so we tighten it down. As soon as I find a 1/2 inch wrench, I'll tighten it down. Okay, 1/2 inch. Here's a 1/2 inch wrench. I tighten this down. Okay, so we're pretending that the cast iron gear is, because I had to change this one too. The cast iron gear is still in there. So we're going to pretend this is cast iron gear. So then, what you do is you press down on this, take out the play, and then we're going to feeler gauge in between the block and the gear and see what it is. Because, maybe from the factory, maybe they got that cast iron gear set perfect to your block. I don't know. You don't know, so we're going to check it. But I already put this bronze gear on there. So I bet you it's going to be about 6 thousandths. Let's see how close I am to that. I hold it down and I feel it. No. Okay, let's try 10. And let's see if I can 10. Here's 10. Okay, again, I'm holding it down. See what I got in there. Okay. So if I let up on it, the 10 goes in. If I hold on it, so it's less than 10. Let's try a 9. All right, let's try an 8. An 8 slides in, so it's 9. Okay. Mine's set for 9. Sometimes getting these exactly where you need it can be pretty tricky. And so I was shooting for 6 and I ended up with 9. So 9's close enough. Yeah, I can't get 9 in there. Not unless I let off on the so okay. So I think it's 8. Let's try 8. See what we need. Okay, so it's 9. It's 9,000. So I got 9,000. So say, you know, you put this in and you got, let's see, you got, and here's the thing about this. This gear and the camshaft are made to be in a certain location in the motor. So if you have this gear 25 thousandths high, I guarantee that even it being a brass gear, it's gonna wear it out. It's gonna wear it out. If you got a high volume pump, high pressure pump, it puts more strain on the gear, and it's prone to wear it out. Also, high volume, high pressure pump takes power, and so I don't run no high pressure, high volume pump because it's unnecessary. That's just what I don't run oversized scroll rotors, high volume, high pressure pump. Okay, so you checked it and say you got 30 thousandths in there. All right. Now what you want to shoot for is you're shooting for probably about 6. This is good. Nine's fine. Don't go any bigger than 9. Don't go any bigger than 9. So anyways, so now you got the dimension here. You know that you got 30. So you want to go 20 thousandths smaller to get to 10. All right. So you're gonna take the distributor back out. Back on the motor. So you know that you gotta go. Pretend we got 30 in there. You want to get to 10. Whoopsies. You want to get to 10. So then you have to take this distributor, and I'm going to try to show you guys here. Okay. So let's just pretend we got 30 thousandths, and you want to get to 10. So you know that this distributor gear, because you got 30 thousandths gap in there, we got to go 20 thousandths this way. So you want to take an accurate measurement. So you got to get yourself verniers. This is how I do it. And I got a little mini me square, and I hold the square right there on that gear, just like that. I hold it on that gear nice and straight, because I want the most accurate measurement that I can get. So I'm gonna hold it on there. Somehow, some way, I'm gonna hold it on there. I'll hold it on just like that. All right. Now I take my verniers, and I'm gonna get the exact dimension from the bottom of this gear to where it lays on the block. Bottom of that gear to right where it lays on the block, right where it sits on the block. I want to get that dimension. All right, we want a nice accurate reading on that dimension. So, just like that. I get that dimension. Okay, so whatever that dimension is, you know, you get an accurate dimension from here to here, from here to here. Whatever that dimension is, you want to add 20 thousandths, because we got 30, you want to be at 10. Okay? And that's how you properly set the gear on the distributor. So like I said, you don't know what it's going to be. I'll show you on mine. Okay, so this is why I had 20 thousandths here. 4020, because that's what this motor ended up being. In order for me, and I got 9 thousandths in there, I had to set this gear at 20 thousandths, and that gave me 9 thousandths clearance. So that's just 4.020. So I would say that you know, I could have gone 4.025. Okay, would have been probably a little bit tighter, but that would have gave me 5 thousandths clearance. Well, it would have gave me 4 thousandths clearance. So anyways, that's the proper way to set the distributor gear. I hope you guys, I hope we made it clear enough anyways. Like I said, all motors are different, you really don't know, but I would go closer to SVO's dimension. You know, this is Ford Motorsport dimension more than the MSD, because what I've found in the past is usually it's right around this dimension, 420, 425. But I said that don't do that. Put the distributor in the motor, put the feeler gauge, see what you got, and figure out the dimension between here, and the bottom of that distributor gear, and figure out what that dimension is and put it right where it needs to be. Don't guess. Put it right where it needs to be. Because if you guess, it's going to be bad. Believe me when I tell you. Okay, so I'll get back to you on my next move. See you soon.